So you see a polynomial function here, and you see how if we read it, if you look at it from left to right, right? We always look at functions from left to right. You'll see that it's sort of, decreasing, and then it starts to increase, and then it starts to decrease again. So here at point A, we have what we call a relative maximum. What does relative maximum mean? As the graph approaches that point A, it's increasing, right? And then after that, it switches to decreasing. So at point A, the graph switches from increasing to decreasing. It changes direction from increasing to decreasing. So over there, we have what we call a relative maximum. Now look at point B. If we're looking at the graph from left to right, this is why I don't like to do arrows at the end of my graphs, right? Because ignore that arrow here at the top left corner. If we're looking at the graph from left to right, as we're approaching this point, the red point B, the graph is decreasing, and then over there it switches to increasing. So if it changes from decreasing to increasing, we say it's a relative minimum. Two new words so far: relative maximum, relative minimum. Right? You can locate them from far away. Basically, a maximum looks like a what? It looks like a peak. A minimum looks like a valley, right? And remember when we were talking about quadratic functions and parabolas, we said if a parabola looked like this, it had a minimum, remember? And then if a parabola looked like this, it had a maximum. So now if you have a function that has both a maximum and a minimum, we say each one is a relative min, relative max. Okay, a minimum and a maximum together, they're also called extrema. So if I say, where are the extrema of this function? You say, oh, there was a relative max here, there was a relative min here. Now, what happened at point A and point B? We said the graph turned around, right? It went from increasing to decreasing, from decreasing to increasing. So mathematicians are so clever and so, original when they're naming things. The points where the function turns, they're called turning points as well. Okay? So, extrema, turning points, or minimum or maximum. Okay, we talked about what the degree of a function was, right? And everybody on the homework had gotten those questions correct, so good. So we know what the degree of a function is. If a function has a degree of n, then the graph can have at most n minus 1 turning points. So for example, suppose you have f of x is equal to x to the 6 plus x to the 4 minus 2. What's the degree? 6. Degree is 6, so it has at most 5 turning points. Okay? Does it mean it has to have 5? No, but it could turn around 5 times. Okay, so for example, 1, 2, 3, 4, 5. Okay, not any more than that. Okay? Okay. So, you remember when we were talking about parabolas and you had to find minimum and maximum on the calculator? It's the same thing with polynomial functions. We find minima and maxima the same way. The thing is, here, okay, I copied and pasted off of the parabolas page. So here, it would have to be not vertex here, but extrema. I mean, it doesn't really matter. Okay? All right, so let's use our graphing calculators to do this one. Okay, so this is what it looks like, right? Can we see any of the maxima or minima? No. So I'm going to change my windows. I'm going to go to 4, menu 4, 1 for window settings. Xmin and Xmax, I'll just leave them the way they are. But Ymin and Ymax, okay, so I don't know how high or how low this goes. I'm just going to put in, negative 15 randomly, and then 15. Look, that's not even enough, so I got to go more. So maybe let's do negative 25.
After you go to window, where do you go?
1 for window settings. Oh, that's good. Oh, look at that. Pretty. Okay. Negative 25 and positive 25. Okay. So now we're going to press menu, right? I'm going to follow these instructions now. To find the minima and maxima. We're going to hit 6. You can either press 6 or analyze graph. Choose minimum or maximum. So first I want to find my maximum, just because. 3. And now lower bound. So maximum, it means we're going to find the peak, right? Lower bound, drag this to the left of it a little bit. Enter. To the right of it a little bit. Enter. And there's your point. 1.87, 22.7. So I say, it should be the same. Did everybody else get 22.7?
Yeah. I mean, honestly, I think it's
No. So we say relative max. We say it's at negative 1.87, comma 22.7. All right, and go ahead and find the min. So relative min, 1.52, negative 17.2. Okay? Questions on this? All right, so let's move on. We're going to sketch, so we're going to go backwards now a little bit. We're going to sketch the graph of a polynomial function with the given characteristics. We want an even degree function, not an even function, but an even degree function with zeros at negative 2, 1, 3, and 5. There could be more than one answer for this. So an even degree function with zeros at negative 2, at 1, at 3, at 5. What does it mean that it's an even degree function? Yes. They either both go up or both go down. So there could be more than one answer. Like I said, you choose whether you want to make it go up or down. Let's say they both go down. So I go here. I need to cross the x-axis. And now it needs to turn around, hit again, turn around, hit again, and go back down. Okay? So even degree because they both go down. Who's that? Could somebody turn that off? Okay. All right, so let's do this one. Now we want a 5-degree function with zeros at negative 4, 1, no, negative 1, and 3. And I want a maximum at x equals negative 2. At x equals negative 2, there has to be a maximum somewhere. All right, I'm just going to put it there. It doesn't specify where. I'm just going to put it there. 5-degree function means one end up and the other down. Okay? So what if we make it look like this? Does that work? Yeah, that works. Again, can there be a different variety? Yes, but that's pretty much what we're looking for. Okay? All right. I'm going to give you now 15 minutes to finish these problems in class right now. Go.